So yeah, I think the best way to describe this is if you think of the Internet of Things of being a nervous system, and sensors being the nerve endings, and digital twins being the intelligence or the brain and the interface behind that. And we could really use these, we can use these tools to really optimize energy performance, as amongst other operations inside the buildings. The key point is to understand how air quality and our exposure to it impacts our health and well-being, as well as our performance, wherever we are, whatever we're doing. So with the Twin Air project, just as I said, with the nervous system and the intelligence, if you picture that again, and we have a situation, I'll give two situations this time. One is acute exposure to poor air quality, and one is long-term exposure to air quality. So the first, the acute, would be, say, something like carbon monoxide. And that can be fatal in short-term exposure, and it has no smell, or it has no smell, or you can't see it. And so with this Internet of Things and the digital twins, this acts as a sensor, and it can find out where there's a leak or where this exposure occurs in the building, and it can alarm or alert the occupants. But not only that, if you couple this with building automated controls, the building can actually do something about it. So it can alert the person, but it can also open windows or turn on the ventilation systems to get rid of the exposure, or reduce the risk of exposure. And these are really fascinating tools that can really help save lives in the future. But going back to the long-term exposure, there's other elements and other pollutants in the air that we don't notice, but over long-term exposure can have severe impacts on our health. If we just take black mold, for instance, that can have detrimental impacts on your health. But we don't really, we can be in rooms and not know we're being exposed to it because it grows behind furniture and it's in places we don't see. So using this digital twin Internet of Things approach, the building can actually identify areas where it's at most risk for I suppose an environment that promotes this mold, where it's 60% moisture all time around. And we wouldn't understand that or grasp that in time and space, because it's like the metaphor frog in the boiling water. You know, you'll know it if you hit it straight away, but otherwise over a long-term period, you won't know you're being exposed. And so the building then can, through the digital twin, let the occupants know that there's risk of mold, but also risk of exposure to mold. So for long-term exposure, digital twin can then identify other components that we wouldn't notice that have big impacts on our life. I guess what's key is that buildings don't really consume energy, but people consume energy. So understanding how people interact with their environment and trying to predict our behaviors is a vital tool when it comes to demand response and say grid networks. I think of a good example of this in one of IES's projects called Escher, where we have a bunch of smart buildings and we're trying to understand how to optimize their energy use. And what we find is that personas, or getting building personas or profiles, really helps to optimize on-site renewables. So we take one building, for example, where we have a stay-at-home parent, and if we were using standard benchmark or practices that you would normally use in the field, we would end up with an energy profile that doesn't represent what they do. And when we take their profile, we see that they're not even utilizing all their local renewables that are with this smart building. So we have this profile, the user persona, and we have two approaches. We can engineer the response, where we use local energy to meet their needs. But when we know their persona, we know their profile, we can predict when they're going to use a lot of energy. And we can ask the person to actually change their behavior to not use energy at those peak times through incentives, such as financial or moral incentives, or just comfort incentives. And taking this example from the Escher project, we were able to increase the energy efficiency of the building, but reduce their energy bills at the same time. and making the occupant more aware of their actual energy habits. Yeah, digital twins, we have various different types, but in our business, we deal with data-driven or actual data, which is what's really happening, and predictive, which uses a combination of models and physics models to understand how a building will perform in a certain situation. The issue arises back to the persona aspect that we described earlier. We can assume a building will perform at a certain level based on its physical attributes. But without the people in it, we don't really know how they're going to use it. And so these kind of smart technologies and the Internet of Things will help us understand how people interact with their space. And it will help reduce something we call the performance gap, where it's the predicted energy based on a building because we think it's new and it's going to work this way. And then the actual energy, which is how people interact with it. So our digital twins can actually cater for both and calibrate using the real world energy. And so, this really helps reduce this performance gap, but it also makes us better understand how to actually manage the buildings, but also how to, make them better moving on to the future. So this really ties into a new European initiative called the Smart Readiness Index. So originally the EPC, which is the energy performance certificates, are still existing, but they only tell one part of the story. And the hope is with the SRI, we can merge these two together to really get a better picture of what's happening on the ground.